It began without warning. A colossal force, born in the silent, crushing darkness of the deep ocean, unleashed its fury upon the world. On this day, June 15, 2025, our planet witnessed a spectacle of raw, untamed power. A wave of unimaginable proportions, a true mega-tsunami, rose from the sea. It was not merely a large wave, it was a moving mountain of water. It towered an astonishing 650 feet into the air, a liquid skyscraper racing across the surface of the sea. This was nature in its most extreme and humbling form, a stark reminder of the immense energies that churn constantly beneath the tranquil blue facade of our world's oceans. Imagine standing on a coastline looking out at the horizon. Suddenly, the sea pulls back, exposing the seabed in an eerie, unnatural silence. Then, it returns. But it is not the familiar rhythm of the tide. It is a wall of churning gray water blotting out the sky. This is what remote cameras captured on that fateful day. The wave was so massive, so powerful that its energy did not just travel across the water, it shook the very foundations of our planet, sending tremors through the solid rock of continents. It was a global event, felt thousands of miles from its origin, a testament to the interconnectedness of our living world. The sheer scale of this event is difficult for the human mind to fully comprehend. A 650-foot wave is taller than a 60-story building. It carries with it the force of thousands of nuclear explosions, an unstoppable momentum that can scour landscapes clean down to the bedrock. It moves at the speed of a jet airliner, crossing vast oceanic basins in a matter of hours. The sound it would make upon striking land would be a deafening, thunderous roar, a cataclysmic noise that would drown out all else. This was not just a wave, it was a geological event, a reshaping of the Earth's surface in a breathtakingly short span of time. This mega-tsunami, born in a remote, uninhabited region of the Pacific Ocean, served as a profound wake-up call for all of humanity. While it struck an unpopulated area, its existence was captured in unprecedented detail. Our silent sentinels, the network of satellites orbiting high above, saw it all. They tracked its journey, measured its incredible height, and recorded the subtle and dramatic ways it altered our planet. For the first time, we had a front-row seat to one of Earth's most violent displays. The data gathered provides a chilling yet invaluable glimpse into the planet's awesome and sometimes terrifying power. It is important to understand that the term tsunami covers a wide range of phenomena, but what occurred was something altogether different, something far rarer and more potent. A regular tsunami, the kind we are more familiar with, is typically generated by a massive earthquake on the seafloor. This is known as a subduction zone earthquake, where one tectonic plate slides beneath another. This movement can displace a vast column of water above it, creating long, fast-moving waves that are often barely noticeable in the deep ocean but grow in height as they approach the coast. They are incredibly destructive, yet they are dwarfed by the sheer might of a mega-tsunami. A mega-tsunami, by contrast, is not born from the shifting of tectonic plates alone. It is the result of a sudden massive displacement of water caused by a singular cataclysmic event. Think of it like dropping a colossal boulder into a pond. The splash is immense and immediate. These events are often triggered by giant landslides, either above or below the water's surface, or even by the impact of an asteroid. A massive chunk of a mountain or a huge section of the continental shelf, suddenly giving way and plunging into the sea, displaces a truly staggering volume of water, creating a wave of immense initial height. The key difference lies in the initial height and the nature of the wave itself. Regular tsunamis are born with a relatively low amplitude in the deep ocean and build their destructive power as they shoal near land. A mega-tsunami starts its life as a monster. The 650-foot wave of 2025 was already a behemoth at its point of origin. This is why it is called a mega-tsunami. Its scale is on another order of magnitude entirely. While a large tectonic tsunami might reach heights of 100 feet, a mega-tsunami can be many times taller, capable of surging miles inland and climbing up and over coastal mountain ranges. This distinction is crucial for understanding the threat. While both are dangerous, their origins and characteristics demand different approaches to detection and preparation. Tectonic tsunamis are linked to seismic activity, giving us a potential, albeit short, warning. Mega-tsunamis from landslides can happen with far less warning, triggered by geological instability that is much harder to monitor. The 2025 event was a stark lesson in this frightening reality, demonstrating that the ocean holds the potential for surprises far greater than we had previously modeled or prepared for, forcing us to reconsider the very definition of a coastal hazard. The colossal wave of June 15th was not born from a shifting of continents, but from a catastrophic failure of the seafloor itself. In a remote and geologically unstable trench, an enormous underwater mountain, weakened over millennia by seismic pressures, finally gave way. An immense slab of rock and sediment miles wide detached from the continental slope and plunged into the abyss. This single event, a submarine landslide of epic proportions, displaced billions of tons of water in an instant. It was this violent vertical shove that gave birth to the 650-foot monster. The ocean surface bulged upwards, then collapsed, sending a ring of unimaginable energy radiating outwards. The power unleashed was almost beyond measure. The energy from the landslide did not simply create a wave, it rippled through the very fabric of the planet. It generated powerful seismic waves, the same kind of shock waves produced by a major earthquake. These waves are not confined to the water. They travel through the solid earth, a vibration that spreads across the globe. Instruments thousands of miles away in different continents registered the event. Seismographs in Europe, Asia, and the Americas jumped to life, recording the distinct signature of the landslide. The planet itself rang like a bell, struck by a hammer blow from the depths of its own ocean. This global seismic footprint is a critical piece of the puzzle. It allows scientists to pinpoint the event's location and estimate its magnitude with incredible precision, even without seeing the wave itself. By analyzing how these seismic waves travel, their speed and their strength as they arrive at different monitoring stations, we can build a detailed picture of the event that triggered them. The seismic data told a clear story. This was not a typical earthquake. The signal was different, characteristic of a massive, rapid displacement of material. The telltale sign of a landslide, a collapse of part of the Earth's crust into the void. The journey of the wave itself was a spectacle of physics. In the deep ocean, it traveled at over 500 miles per hour, its immense energy hidden within a long, low swell. But as the seafloor rose towards remote, uninhabited islands in its path, the wave began to slow down, and its energy compressed. Like a whip cracking, this compression forced the wave's height to grow exponentially. What was a low, fast-moving swell in the deep became the towering 650-foot wall of water that was observed. It scoured these small islands clean, a demonstration of the fate that would await any populated coastline unfortunate enough to be in its way. The seismic waves generated by the underwater collapse embarked on an incredible journey through our planet's interior. Imagine dropping a pebble into a still pond, ripples spread across the surface. Now, imagine that pebble being the landslide, and the pond being the entire solid Earth. The waves of energy known as seismic waves travel not just across the surface but through the very core of the planet. There are primary waves, or P waves, which are compressional waves that travel fastest, pushing and pulling the rock as they move. Then come the secondary waves, or S waves, which move more slowly, shaking the rock side to side, like a snake slithering. These waves are the planet's internal messaging system. As they travel through different layers of the Earth, the crust, the mantle, the liquid outer core, and the solid inner core, they change speed and direction. It is this behavior that allows seismologists to map the Earth's interior, a place we can never physically visit. The seismic waves from the 2025 mega-tsunami provided a uniquely powerful signal. They acted like a planetary-scale ultrasound, allowing scientists to refine their models of the Earth's structure. Every seismograph that recorded the tremor added another piece to this complex global puzzle, revealing the hidden architecture of our world. But the story was not only being told within the Earth, it was also being written in the sky. High above the atmosphere, a constellation of satellites, our silent sentinels in orbit, turned their unblinking eyes towards the event. Satellites equipped with radar altimeters are incredibly precise. They work by sending a microwave pulse down to the ocean surface and measuring the exact time it takes to return. This allows them to measure the height of the sea surface with an accuracy of just a few centimeters. As the mega-tsunami propagated across the Pacific, these satellites mapped its progress, capturing its astonishing height and speed in real time. This view from space is revolutionary. Before satellite altimetry, our understanding of tsunamis in the deep ocean was largely theoretical. We could only measure them when they arrived, tragically, at the coast. Now, we can watch them form and travel. The satellite data from the 2025 event was chillingly beautiful. It appeared as a distinct, massive ridge of elevated water moving inexorably across the vast blue expanse. This information is not just scientifically fascinating, it is a lifeline. It provides concrete, undeniable proof of the threat and gives us the ability to forecast its arrival time and potential impact with unprecedented accuracy, forming the backbone of modern warning systems. The data captured by our orbital fleet of satellites is more than just a collection of fascinating images and measurements. It is a critical tool for human survival. In the aftermath of the 2025 mega-tsunami, scientists had a treasure trove of information. By combining the seismic data that showed the landslide's origin with the satellite data that tracked the wave's path, they could build and refine computer models. These models are essential for forecasting. They allow us to simulate what would happen if a similar event occurred elsewhere, helping us identify vulnerable coastlines and predict how far inland a wave could travel, providing the foundation for effective emergency response and evacuation planning. Now take a moment to imagine. Imagine that this 650-foot wave was not born in a remote trench. Imagine it was triggered by a landslide off the coast of a major metropolitan area, a city like Tokyo, Los Angeles, or Sydney. The consequences are almost unthinkable. A wall of water taller than any skyscraper would descend upon the city at the speed of a jet. It would not just flood the streets, it would obliterate them. Concrete and steel buildings would be torn from their foundations. Bridges, ports, and entire neighborhoods would vanish in moments. The loss of life would be catastrophic, and the economic and environmental devastation would be felt for generations. This scenario is not science fiction. The geological record shows that mega-tsunamis have happened before in Earth's history, and the 2025 event is a stark confirmation that the forces required to create them are still very much active. It highlights a profound truth. We live on the thin, fragile crust of a dynamic and powerful planet. While we build our civilizations with an assumption of permanence, nature operates on a different timescale, with forces that can undo our work in an instant. The satellite images of this colossal wave are a humbling reminder of our place in the natural world. Therefore, the ultimate lesson from the day the ocean roared is one of respect and readiness. We cannot stop these immense natural events. We cannot tame a mega-tsunami, but we can understand them. We can monitor the geologically unstable regions of our planet. We can invest in the science and technology like our satellite networks that give us the gift of foresight, and we can prepare. By fostering global awareness, creating robust evacuation plans, and educating communities about the risks, we can empower ourselves to act when nature unleashes its greatest fury. Our survival depends not on controlling the planet, but on listening to it and heeding its powerful warnings.